So, good morning to one and all. Myself, Anitha V, Assistant Professor from Artificial Intelligence and Data Science Department, Arunai Engineering College, Thiruvannamalai, Tamil Nadu. So, my topic is the computer vision. So, this is the today's agenda about the computer vision. So, first one is the introduction to computer vision, evaluation and milestones, key techniques and architectures, applications across domains, deep learning integration, challenges and ethics, future trends, and conclusion. So first, we have to go for the what is computer vision. So in the field of AI that enables machines to interpret the visual data, that is the computer vision is a specialized subfield of the artificial intelligence that focuses on enabling the computers and machines to understand, analyze, and interpret the visual information from the world. So visual interpretation means such as the images, videos, or real-time camera. So just like the humans can use their eyes and brains to perceive the environment, whereas the computer vision system uses cameras and algorithms to see and extract meaning from what they want to capture. So it converts the pixel into the actionable information. That is computer vision. It takes raw pixels and convert them into the meaningful insights, that is identifying object, recognizing faces, detecting motion, measuring the distance, or classifying the scenes. This transformation from data to decisions is what makes the computer vision so powerful in nowadays in AI systems. So next one is the computer vision can be inspired by the human visual representation. So it can be as a techniques can use as the conventional neural networks. It stimulates how our brain patterns, how they can be as the flexible computer vision as the suppressed human accuracy in certain tasks like tumor detection or facial recognition under the control. What are all the control settings is there? So applications it can be range from the security to healthcare and beyond. This is the big for the presentation. So the real world impact of the computer vision is fast. Excuse me. It can be used for the security systems, healthcare, retail system, agriculture, autonomous vehicles, like that. Next, we have to move on the next slide. It has the vision pipeline. Vision pipeline in the computer vision. So first one is the accusation, next one is the pre-processing, future representation, and next one is the model inference and post-processing. So first is the accusation. Accusation is the capturing images, videos via the sensors. So the first step in the computer vision is the data acquisition. It involves the capturing visual data using images such as digital cameras, webcams, sensors, drones, or even medical scanners like MRI and X-rays. The quality and type of sensors, it could be greatly influence the downstream performance of a CV model. For example, we can take it as a self-driving cars. Self-driving cars, it include the infrared sensor, visible light to perceive what are all the surroundings in that roadways. So next one is the pre-processing. Pre-processing, it can be mainly used for the noise reduction and normalization. So once the images or videos are captured, they must be cleaned and standardized through the pre-processing. This includes like resizing, contrast enhancement, color correction, and the noise removal. So pre-processing is essential because even slight variation in the lighting orientation, it can lead to the poor result. So pre-processing technique is the very important one. So next one is the future representation. In future representation, we have to use the techniques like hog, that is the histogram of oriented gradients. And next one is the shift. It is a scale invariant future transform. These are all the CNN technique, that is a conventional neural networks technique. So in modern systems, however, deep learning has replaced the manual feature engineering. So conventional neural networks, it automatically learn hierarchical features from data, capturing everything from basic edges in early layers. So next one is the model inference. Model inference, it predicating the classes, objects, or scene. So it typically a trained neural networks to make the predictions, segmenting a scene into the meaningful regions or estimating the motion of the pictures. It all comes under the model inference. Next one is the post processing. Post processing is the filtering, localization, and interpretation. So this is the final stage. The final stage involves the refining the model output for the practical use. It can be the drawing the bounding boxes, applying the non-maximum suppression to remove the duplicate detection. So in real world systems such as alerts, robotic environment, user interfaces, it's all comes under the post processing. So it could be the filtering the process, that is model output for the usage of the purpose. So next we have to move on the evaluation of the computer vision. So in 1960s, the basic line edges detection, we are using the rules. So whereas it begins with the experimenting with a simple rule-based system, that is processing the task, detecting the lines, edges, and boundaries using the mathematical filters. So this idea was mimic to the human's retina response to the intensity of changes. So next we have to move on the 1990s. 1990s, it has a geometric modeling and the future extraction. So in 1990, it allowed computers to interpret the 3D scenes from the 2D images, such as corners. So they have to enable the better identification and shape analysis. So next in 2000, it can uses the uh, classical ML and the neural networks plus some hand created the features. So in that we have to use the CNN techniques, as a shift scale invariant feature. It can be used. These features were then classified using traditional ML algorithm, that is machine learning algorithm. It supports the SVM technique, that is support vector machine. Next one is the K nearest neighbor neural networks. So it can be the powerful. This approach required a deep domain learning basics. So next one, 2012, it has the deep learning visual understanding. So a major breakthrough can be occurred in the 2012 only. So when Alexa net, that is a deep convolutional neural network, that is CNN, it can be on the ImageNet large scale visualization. So this marked the beginning of the, in 2012 it could be as the beginning of the deep learning era in computer vision. So the models eliminate the manual feature engineering by automatically learning complex representations from the raw data. So next 2020s, it can be foundation of the model and self-supervised learning. So in that they include the many ML algorithm. They can include the deep learning algorithm to can generalize the task domain. It can combining the vision and the language understanding. This field is nowadays moving towards the general purpose of the visual intelligence. So this is the evolution of the computer vision. So next we have to compare with the human vision versus computer vision. So human vision is a context aware and intuitive. So first in that in that mission vision, the input is there, sensing device is there, and then mission, after that output is there. So in normal human vision, one object is there, afterwards we have to interpret with our eye and we are using the brain. So afterwards we have to produce the output. So human vision is not just about recognizing the objects, it is deeply tried to context, memory, reasoning, and previous experience. So we can understand a partially visible object to recognize the people or identify based on the previous patterns. So, but CV depends on data, compute, and structural learning. So, in contrast, CV it can be used for the labeled data and the computational power. So depends on data, compute, and structural learning. So without balanced data, the system often fail to generalize the models. So while CV models can perform like facial verification, they can lack the flexibility and adaptability of the human perception. So next one is the biological neurons inspire the artificial CNNs. So in modern deep learning techniques, especially CNN is a biologically inspired, so it can form the simple edges and textures to complex shapes and faces. So nowadays, the plastic nature of real neural networks in the human brain, the structure of artificial neuron is the still compared to the, it could be as the simplistic to the dynamic. So next one is the human vision. Human vision is the more robust to noise, articulation and motion. That is, human can easily recognize familiar faces in poor lighting, read signs partially covered by the other objects. It makes sense of blurry or fast moving the images. But in CV, on the other hand, it can struggle with some minor changes, robotness and generalization to remain the major challenges in building the vision system. So compared to the human vision, next we have to move on the type of computer vision. Type of computer vision, first one is the image segmentation, object detection, facial recognition, edge detection, pattern detection, image classification, feature matching. So first one is the image detection. Image detection involves dividing the image into multiple regions or segments to simplify or change the representation of the images. For example, we are using the autonomous driving. Segmentation can be classified into every pixel. They have to distinguishing the road, pedestrian, vehicles, and sidewalks. So in the image segmentation, it has the two types, semantic segmentation and instant segmentations. That is, we can label as a car. So each car has a unique ID. So for the understanding purpose, they are giving the semantic segmentation and the instant segmentation. Next one is the object detection. Object detection identify what objects are present and where they were in an image. So it could be as the modern approaches like neural networks, that is conventional neural networks. It is the capable of detecting multiple objects in the real time with high accuracy. So next one is the facial recognition. So widely it can be used in the used can be for the authentication purpose. Nowadays we are using in the phone, that is unlock pattern. So wherever security or research is there, medical field, whatever, the facial biometric has been nowadays grown rapidly. Uh, though it also raises the privacy and the ethical concerns also. So next one is the edge detection. Edge detection is the low-level CV detection. That is, it identifies the boundaries within the images by detecting changes in the brightness or textures. So this process is foundational to object recognition, image segmentation, and structure formation in the robotics. So next one is the pattern detection. Pattern detection is used to identify the requiring visual arrangement, such as wheels in machinery, textures in fabrics, so like that. So whereas visual patterns indicate the structures in that pattern recognition. Next one is the image classification. So image classification assigns a single label to an entire image. For example, cat, a car, a tree. It is the most fundamental CV task. It forms the it has the backbone for the many complex tasks. So conventional neural networks and transfer learning are widely used to achieve the high accuracy. Last one is the future matching. So in that future matching techniques, it has the how it can find the similarities between the two images. That is a 3D reconstruction. It can be useful for the panorama stitching. So like that, many algorithm can be used for the future matching. So next we have to move on the image representation and processing. So in image representation, image it can be as the numerical arrays of the pixel intensities. That is, the pixels array can be processed mathematically and manipulated through algorithms and forming the input foundation of any computer vision model. So second point is the pre-processing enhances the input quality. That is, before we have to enter the model pre-processing, it is a crucial to standardize input formats and the remove the artifacts. That is, it could be as the resizing is there, normalization is there, noise removal is there. So resizing means we have to check with the ensure the all images it could be as the consistent dimension. So next one is the normalization. Normalization is the pixel values. Noise removal, we have to remove the excess affects the model performance. High quality processing to improve our model robustness. Color spaces, so we have to know RGB is the red, blue, green. It is a standard for the screen display, but is sensitive to the lighting. So HSV is the hue saturation value. It can separates the color information from intensity, useful in object tracking and the color filtering. So LAB space models, that is human vision more closely, and it is preferred in the perceptual image. So these are the color spaces, RGB, hue saturation value. So next, what are all the library functions can be used means OpenCV, Pillow, OpenCV, Pillow. Next one is the Scikit image. It can be used extensively. That is, several open source libraries make image processing accessible and efficient. So OpenCV is the open source computer vision library. Open source computer vision library, Pillow, Scikit image. So these are all the open source library for making the image processing. So Pillow is a user-friendly Python library for basic image manipulation, like how we can edit our photo, that is the cropping, filtering, and we can use for the format conversion. Scikit image, it can be used for the scientific and academic applications for future extraction, restoration, and morphology purpose. These libraries serve as the building blocks of the computer vision systems in both research and the production. So next we have to move on the future extraction techniques, that is the DL techniques, deep learning techniques. So first one is the shift and surf. So we have called it as the scale way invariant future transform. Speeded. Next one is the surf is the speeded up robust future. These are all the two most influential algorithm. So it can detect the robust key points under some scaling process or rotation process. These features enable reliable matching across multiple views or zoom levels, critical in tasks like image stitching, object recognition, and 3D construction. So next one is the hog. Hog is the histogram of oriented gradient. So it is the one of the conventional neural techniques. It became very popular due to the effectiveness in directing human figures in images. So how it can captures the image means it can captures edge and shape information, and they have to reduce the noise and the lightning. So it can support the SVM techniques, that is support vector machine for real-time detection. So next one is the ORB. ORB is the oriented fast and rotated brief. It is a lightweight alternative for real-time application. So ORP detect the key points and creates a binary descriptives that are fast to compute and match, making it ideal for the real-time vision applications like the localization, mapping. So many application is there. So next, limitations, it could be as the sensitive to noise, lightning, and deformation. So next, paved the path for the learned future sphere CNS is the what is the idea, key point detection and future description inspired by the development of the CNS networks. So next we have to move on the traditional object detection approaches. So in the traditional object detection approaches, so first one is the sliding window plus her cascades. That is, it can use the hog plus SVM techniques. So hog is the, already I said, histogram of oriented gradients. Histogram of the oriented gradients, and SVM is the scalable vector machine. So here, before the rise of the deep learning, it could be heavily relying on the sliding window approach. That is the sliding window plus classifier approach. So first, an image was extensively scanned at different levels and positioning using small fixed size window. Each window can pass through the classifier like her cascades. That is, Hair cascade is one of the simple algorithm. It can be used in the earlier face detection. So to check the objects. So next one is the template matching. Template matching, it defines the comparing the subregions of an image with the predefined templates using the correlation or similarity metrics. So next one is the region proposal methods. That is the region proposal methods means to reduce the inefficiency of scanning every possible window. So region proposal techniques like selective search were developed. So next one is the limited robustness and speed for the dynamic environment. In real time, it was very impossible because of the computational load. Additionally, we can useful for the future engineering purpose. Many algorithm techniques we can for the security purpose we have to use that. So next one is the precursor to deep detection architecture. That is modern deep learning based detectors. So we have to, despite the limitations, it can be used for the conceptual groundwork for the modern techniques. What is the rise of deep learning in the computer vision? So when it can be applicable for in the deep learning, the computer vision. So deep conventional neural networks, it has to be enable end-to-end future learning. That is one of the introduction of the CNN, that is convolutional neural networks. It has to be separate future extraction and classification for learning the raw data image into the end-to-end manner. That is, this network automatically learns the patterns such as the edges, textures, and shapes at the different level of abstraction. So next one is the reduced need for manual future engineering. That is, this manual engineering was the time-consuming task specific, and often failed to generalize across different environment. With deep learning, these steps are automated, allowing the model to discover optimal features on its own, making it adaptable to a variety of domains and data types. Next one is the leverage a large scale data sets. So in that we have to use the learn a rich visual representation that could be transferred to down many downstream risks. So it can be marked at the beginning of transfer learning in computer vision, that is predefined networks or fine-tuned for specialization applications with minimal data. So it can be used for the ImageNet, for example, ImageNet and similar data net. It can be powered the deep learning explosion in the computer vision. So this marked as the beginning of the transfer learning in computer vision, whereas pre-trained networks are fine-tuned for the specialization applications with minimal data. So in that we can use for the ImageNet and similar data sets are provided. So next we have to move on the CNN architecture. So evaluation of the CNN architecture. So first we have to start with the convolutional neural networks. In 1989, it was the earliest practical demonstration of the convolutional layers and back propagation in a neural networks. And next in 1998, it is a LeNet. LeNet is the Pinode convolutional neural networks. So it could be recognize the handwritten digits only. So after that it should be recognize the handwritten digits only. Next we have to move on to the 2012. It is the Alexa net sparked by the deep learning revolution by dramatically winning the ImageNet challenge. So next we have to move on to the Google Net. Google Net, it could be as the 2014 introduced. It introduced the inception modules. It has the V2, V3 and V4. It can be achieved high accuracy compared to the AlexaNet. For it could be focused on the computational efficiency. Next one is the VGG 2014 only. It often used as a future extractor in the transformer learning. So same as that, compared to the Google Net, it could be as the high accuracy. Next one is the ResNet in 2015. It is the become backbone for the many computer vision system due to its high performance, and it could be mainly ensures the stability. So next one is the DenseNet. DenseNet in the 2016. DenseNet, it can be introduced by the dense connection. That is, each layer connects to the every other layer. It promoted the future reviews and improved gradient flow, leading to the more compact and efficient networks. So next one is the channel Re- ResNet is the 2015 to after the evaluation of the 2015, it moves to the 2017. It added a idea of grouped conventionals and modular design. It becomes popular in ensemble and classification heavy pipeline techniques. So next we have to move on the channel boosted CNN. Channel boosted CNN, it could be as the 2018 to 19. It focused on enhancing the channel wise future representation. It could be used in the application. It requires the high level descriptive features and then high level recognition. So next we have to move on to the 2019 to 2020. It is the efficient net. Efficient net, it introduced a scaling methods such as the depth, width, and revolution. It achieved state to the art performance with fewer parameters, and it could be as the lower computational cost. Next, this is about the overview about the CNN architectures. So first, it could be start with the 1989. After that evaluation of the CNN, it could be as the 1998 a LeeNet. After that, it could be evaluated into AlexaNet, GoogleNet. So next, finally, it could be as the efficient net. So next we have to move on the transfer learning and the fine tuning. So first point here, a reuse of pre-trained models for the new TV task. It could be effective with the limited data availability. That is, instead of training a model from the scratch, we leverage the knowledge that is already learned in the earlier layers, which capture the general visual patterns such as the edge textures and the shapes. So next one is the future extraction versus full fine tuning. Future extraction, it has there are two types. There are two primary extraction. It can be useful for the transformer learning. So first one is the future extraction. Next one is the fine tuning. So first one is the future extraction. Future extraction, it is a pre-trained model and it can be used to extract the future. Next one is the fine tuning. Fine tuning is the pre-trained model and retrain it along the new task. This enables the model to adapt better to the domain specific data. So the choice between the two models, that is two primary strategy, it could be depends on the data size, model complexity, and computational resources. Next, what are the common models can be used in the fine tuning purposes? So already in evaluation of the networks, we saw ResNet, EfficientNet, and the Inception. So it can be widely used for the simplicity, depth, and transfer learning in the computer vision. So next one is the reduces training time and enhances the generalization. That is, since the model has already learned for the many representation, so it could be as a very fast and it could be as a very stable also. Additionally, the transfer learning can improve the generalization, especially when the target data sets is small or imbalanced like that. So next we have to move on with the detection with the deep networks. So first, here some images has been given. Regions with the convolutional neural networks. So first step is the input image, second how they can extract the region proposal, and then they have to wrap the region. So which one we have to need, that is the person or behind that person or horse is many is there. So we have to separate all the images. After that, extract the separate region proposals, and then we have to wrap it. They have to compute it the CNN futures, and then we have to classify the regions. So first we have to start with the input image. The process begins with a raw image. It contains the one or more objects of interest. Unlike the classification, whether entire image belongs to a single label, detection must localize the multiple object. So example here they including the detecting a person riding a horse or multiple vehicles on the road. So next one is the extract region. Extract region is instead of scanning the images with a sliding window, it can uses the technique called selective search. So selective search to extract about the 2000 region proposals are likely to contain the object. So how it can be used the selective search means it groups the pixels into superpixels. and then merges the similar regions based on the texture, color, size, and shape compatibility. This dramatically reduces the number of regions to be evaluated, improving and the efficiency. Next one is the compute CNN futures. Compute CNN futures, it could be as the cropped and wrapped to a fixed size. What are size we have to need? So we have to wrapped and cropped to the fixed size. It has the high level rotation, and then we have to eliminate the background noise. We have to use the such CNN techniques, hog or swift. So next we have to move on the compute CNN futures. In that, importantly, the CNN is applied to the independently to each region, a process that is computationally expensive and slow during the inference in the training. And then region. Next one is the classify the region. Classify the region. It is a set of linear SVM classifiers. It is trying to classify whether the region belong to a particular object category. For example, person, car, horse, what are all the background is there. So it can use the bounding box regression model. So it predicted the bounding box. They have to fit the better object with the each region. So next slide is the types of image segmentation. It has the three types is there: semantic image segmentation, instant segmentation, and panoptic segmentation. So image segmentation is a foundational task in a computer vision, whereas the goal is to assign labels to every image in an image. So it enables the machine not just detect the objects, it can understand the shapes, boundaries, and spatial relationship of all elements within a scene. There are three major types is there. First one is the semantic image segmentation. In that semantic image segmentation, it classifies the every pixel in that image into a predefined set of object. So in the example, all people are labeled as a red, all trees are green, all roads are purple. It provides a global understanding of the scene without distinguishing between the individual objects of the same class. Commonly, it can be used in the autonomous driving, medical imaging, and robot navigation, where where object category is more important than the individual identity. Next one is the instant segmentation. Instant segmentation goes up one step further. It not only assigns the class labels but also differentiate between the individual instance. Each object is treated separately even if they belong to the same class. In the image, two people are marked with different colors. It can indicating the it can it can indicating the separate identities, that is not a just person in a class. It is a crucial for task requiring for object counting, tracking, or interaction. So what are the techniques here? They have to use the conventional neural networks technique, deep mask learning techniques can be used. Next one is the panoptic segmentation. Panoptic segmentation, it is a unified approach that combines both semantic segmentation and instant segmentation. It can uniquely identify the each object, that is instant segmentation, and then like a sky, road, or grass. So like that, in that image humans are individually identified while the sky, trees, and roads are individually identified. It could be treated as the separate classes. So what are the applications here? They can be used means autonomous vehicle, urban scene analysis, drone navigation. So it could be separately analyze the human separately, object separately, road separately, vehicle separately, and the trees also separately. So it is the panoptic segmentation. It is combines the semantic and the instant segmentation. So next we have to move on the video and temporal CV analysis. So in that, while traditional computer vision, it focuses on the video understanding deals, where the sequence frames over time like that. So nowadays we are using the motion tracking via the optical flow or frame matching. That is, a optical flow estimates the pixel-wise motion between the frames, capturing the direction and speed of the object environment. So frame matching, it is a technique such as the template tracking or future-based alignment are used to associate the same object across the time. These methods are foundational in systems like video surveillance, traffic monitoring, and visual recognition in robotics. So what is the challenges means? It has a sensitive to the lightning means, and it will be the camera activity, camera shaking. So it's all the major challenges of action recognition with the 3D CNS or LSTM system. It can recognize actions or events with the 3D convolutional neural networks. It extends the 2D filters. It allowing the motion patterns directly from the video clips. So it can uses the LSTM model, that is long short-term memory networks. It has to use to capture the long-term dependency across the frames. Next one is the applications. Applications, it defines the sport analytics, surveillance camera, gesture control. Sports analytics, we know, tracking the player movement, real-time statistics. Next, the strategy. What are the strategy the player can be used? Prediction, before itself we can predict. Surveillance system, we know about that. We are using detecting suspicious behavior or unidentified object, some unused objects like that. Next one is the gesture control. Gesture control, it has the gaming and sign language interpretation through real-time movement and the understanding. So next one is the temporal coherence remains a critical challenge. That is, temporal consistency across frame remains a key bottleneck. That is, flickering predictions and unstable box detections. It can be say limited model V requiring optimization for real-time especially in dynamic or crowded environment. The 3D vision and spatial understand advanced domain of the computer vision that enables machine to perceive depth, structure, and spatial relationship in a scene. It can be essential for the real-world interaction, autonomous navigation, and immersive experience. Next, they have to use the point cloud processing via LiDAR or stereo vision. That is, LiDAR is the light detection and ranging. It captures the high precision 3D data by measuring the later pulse reflections. So, what is the depth estimation from the single view or multiple view? So, it can be single RGB image to infer the depth about the based on the size and the geometry, scene geometry. So depth estimation is a foundational task for the AI applications, 3D modeling. So we have to detect in the images. So next one is the 3D object detection. 3D object detection, unlike the 2D, 3D objects predicts the bounding boxes in 3D space. How they can predict means with the orientation, position based on the size of the object. So example they given in the autonomous vehicle. So in autonomous vehicle, I mean autonomous driving, we can accurate localization of the pedestrian vehicles, round boundaries, so all the things we have to localize. So next one, use cases. In that use cases, we are using the augmented reality, virtual reality. It accurates the 3D scene understanding for the surface reconstructions. So next one is the robotic navigation. Robotic navigation, we all know about the, so what are the planning? We have to enable the AR devices to localize themselves, manipulations. It should be purely reliable on the 3D scene interpretation. What are the toolkits can be used in the spatial understanding for the 3D vision is Open3D. Open3D is the open source library for the 3D data processing. Next one is the PyTalk 3D. It is a Facebook AI library. It can be used the deep learning with the 3 data. It supports the clouds and the differential rendering. And the next one is the Novita. So it has a high performance 3D toolkit for it could be designed as the GPU accelerator training for the neural 3D representation. Next, we have to move on to the generative models and then computer vision models. So here they are using as the generative models, the new generation, GAN networks, 3D GAN, text to image. So computer vision models, first they have to image classification. After that, they have to go for the object detection. You can, many object is there. Road is there, one image is there, bicycle is there, home is there, house is there, trees is there. So many object is there. They have to identify separately in that, and then semantic segmentation. They have to separate all the objects into the separate color. So after that, we have to move for the estimation purpose. We have to estimate the each and different object. So the relationship between the generative models and the traditional computer vision is evolving rapidly. While computer vision focus on understanding the visual data, generative models specialize in creating it. So today it could be the becoming increasingly they have to be used as the models in that generative models. So here left side is there, it is the generative models. It is first one is the neural radiance fields. So neural radiance field means the it could be the technique for generating the 3D views from a 2D images. That is the NERF. Next one is the 2D. It is a GAN. GAN is the generative adversarial networks. It learns to the realistic images from noise or conditioning. So here they can use the super resolution transferring learning technique. Next one is the 3D GAN. 3D GAN, it is the extension based on the 2D GAN. So it could be mainly used for the 3D visual training data sets, and then shapes, meshes. So all the things here they have to used in that 3D GAN technique. Next we have to move to the text to image. It converts the descriptive text to the high quality images. It integrates the NLP process, that is natural language process. It could be understanding with the vision analysis, that is computer vision analysis. It bridges the gap between the CV and then NLP. Next, we have to move on to the computer vision. In that, first one is the image classification, assigning a label to an image based on its visual content. So next, object detection, locating and labeling a multiple objects in one scene. Next one is the semantic segmentation. It can use the each pixel can be identified. We have to predict all the segmentation mask. We have to adapt the training data set. So next one is the post estimation is the determining the uh, spatial orientation of the objects or people. So here also they can use the 3D GANs techniques to training the our data set. So next one is the innovative solution of computer vision in healthcare. So computer vision is transforming modern healthcare by enabling the automated visual interpretation of clinical data, improving the diagnostic accuracy, enhancing the patient care. So first one is the interactive medical imaging. Interactive medical imaging here, what are the things means? That is MRI scan, CT, X-ray, all of it could be comes under the AI technique only. It could be large scale annotated data sets. Next one is the real-time surgical assistance. Yeah, real-time surgical assistance, advanced CV system, they can guide the surgeons to during the procedures through instrument tracking, risk zone detection like that, integrated with the robotic surgery platform. That is the real-time surgical assistance. Next one is the patient identification. Patient identification is the used a facial recognition, that is scanning or secure patient verification. It can reduce the identity fraudulent in the hospital. It can be useful for the remote clinics and emergency situations, whereas the traditional ID system may fail. What are the we can use the ID card? What are all things? It could be fail only. Seamlessly, we have to in hospital information system for biometric authentication also. Next one is the patient monitoring. Patient how it can be monitored. In ICUs and elderly care, CV enables the false detection, posture tracking, and breathing rate estimation without wearable the sensors. It enables the productive response nowadays. In early detection of the cancer, it is the deep learning model. Now they are revealing or suppressing the expert radiologist in spotting the early detection. This ensures the timely intervention, significantly improving the survival rates. So mainly it could be major commitments in the medical industry. So many is there in computer vision. So next, what are the vision in the autonomous system? In autonomous driving is one of the most advanced and high-stake application of the computer vision. It could be demanding on the precision, speed, and robustness. So first one is the road scene understanding. That is the CV models detect and classify the objects like vehicles, pedestrian, traffic signs, and road lanes in the real time. So sensor fusion, in that sensor fusion, it can combines the visual data with the sensors. That is fusion enhance the reliability with the semantic context. We can easily identify the localization. Next one is the real-time inference under latency constraint. Optimization include model quantization and dedicated accelerators. CV models must operate the latency to maintain the vehicle safety and the responsiveness. So next one is the handling the corner cases. That is, it requires the robot training with the trained data sets. For example, we have to use for the fog, night, and heavy rain, or any accumulations or erratic human behavior. So this could be the challenges for the CV models. Next one is the safety. Safety, we have to assure about that autonomous system require fail-safe mechanism, continuous health check, and explainable in that AI also. So we have to ensure in that redundancy and reliability. It should be mainly on the safety critical in CV. Next, the top 12 computer vision applications. And nowadays, what all things we have to use in that? Nowadays, we are using the cashless store. That is ordering the things through online itself. We can pay it. The ordered things we have to directly came from the home. So it can be technologies like many apps there. We have to use to for the Amazon. We have to go real time tracking and payment integration. All the things we have to done in mobile itself in that app itself. Then cashless store. Next one is the virtual monitors. Virtual monitor is the uh, let customers try on clothes virtually. So yeah, nowadays we are using the body dimensions. It can use as the pose estimation, and the body segmentation to find out the realistic filters. So that is the virtual mirrors. Next one is the excuse me, targeted in-store ads. That is in advertisement. Camera analyze the customer geographics. They have to trigger the targeted stores. That is, ad can dynamically adjust based on the automatically what are the views they need based on the gender, age. It improving the rates. So that is the targeted in-store ads. Next one is the inventory management. Inventory management, that is a smart shelves, cameras, the monitors the each level in real time. So restocking, theft detection. So for what all the things is there, they have to easily capture all the things. Next one is the customer behavior analysis. It tracks the movement patterns and emotional responses. It helps optimize the store layout and product placement based on the interaction data. So next one is the store layout and the improvement. Next one, price and in-store the adjustment. Next one is the barcode scanning. Barcode scanning, we know about the barcode scanning nowadays. Shop is to scan the items, review. We have to identify the nutrition information. So like the things. Next one is the customer mood tracking. So these are also nowadays they are using supply chain management is the SVM price prediction. We have to scan and we have to use the price adjustment, and then we have to use for the in-store adjustment. In-store adjustment is the real-time analysis of busy areas. It supports the personalized pricing and the ad content at the shelf level. Next one is the vision in security and surveillance. So, a computer vision is a modern surveillance systems. It can enabling automation, accuracy, and intelligence in monitoring public and private spaces. However, its deployment also raises ethical and privacy policy. So, first one is the real-time facial recognition. And real-time facial recognition, it detects the identifying individuals across the live video feeds with high precision, useful for the airport, stadium, smart cities. Next one is the crowd behavior analytics and anomaly detection. It can be useful in the event management, public safety. It can trigger the alerts when movements deviates from the established norms. Next one is the license plate and vehicle tracking system. License plates and vehicle tracking system. It can be used for the speed and behavior across the traffic cameras. It can be deployed in a tool both traffic control, parking enforcement, and crime investigations. So border and facility surveillance. So it could be integrated with the sensor surveillance, 24/7 surveillance. Okay. Next one is the raises privacy and misuse concerns globally. So that is continuously surveillance may lead to the misuse and violation of the liberties. That is, it can raise questions around why like that, bias and recognition like that. So we have to pushing the transparent, fair, and accountable AI in the surveillance. It could be better with one. So next one is the tools and frameworks. Computer vision tools and frameworks. OpenCV, open source computer vision library. It supports the Python, Java, MATLAB bindings. It supports object detection, segmentation detection, future extraction like that. Next one is the TensorFlow and the areas. TensorFlow. Next one is the TensorFlow. It is a open source deep learning framework. It can be developed by the Google. It can be extensively used for image classification, object detection. Same as that. Next one is the PyTorch. PyTorch is a deep learning framework. with the dynamic computation high popular in the academic and the research. PyTorch vision, it can include the pre-trained models, that is transform the data sets. Next one is the CUDA and CUDNN. That is CUDA is the Compute Unified Device Architecture. CUDNN is the CUDA Deep Neural Network Library. It primitives for the deep neural networks. So it frameworks like it can be used the PyTorch, that is pre-trained models, so essential for the 3D modeling techniques in the real-time systems. What are the challenges in the modern CV system? So first one is the labeling cost. Yeah, it should be very wide one. So we have to train our data sets, we have to train our models. It requires the cost. The cost should be very high. However, we can train, however, we can complex tasks like 3D labeling. It is intensively costly only. So next one is the domain shift and generalization. Domain shift and generalization is in that, for instance, a model trained on the urban traffic areas, it can be poorly in the rural settings. This can lack the generalization. It can limit the scalability and reliability. What is next one is the vulnerability. Vulnerability is the deep vision models are prone to adversarial because it could be carefully designed to change input images that it can cause the misclassification. So, because we have used it the biometric security healthcare diagnostic, where any error it can be occurred means it could lead to the serious consequences. Next one is the interpretability and the transparency. Yeah, it could be understanding why model can be a particular prediction remains a challenge. This lack of transparency reduces the user trust and complicate deployment in regulated domains like finance, medicine, and public surveillance. Next one is the computational and energy constraint. High computational requirements for training the energy constraint. In large CNS networks, it could be as the substantial computational power and memory. This not only the increases energy consumption, but also limits the accessibility for researchers and institutions without access to the high-end infrastructure. Next, we have to move on to ethical. What are all the ethical concerns in the computer vision? First one is the bias in facial recognition data sets. So many facial recognition systems are trained. This leads to the error rates that arises support the fairness, especially in the law enforcement and border control. So we have to many facial recognitions are trained that can be lack the geometric diversity. Next one is the surveillance without consent. Surveillance without consent is the without informed consents from individuals. Continuous monitoring of behavior, movement, and identity challenges. It could be leads to the privacy. That is the surveillance. Without consent, surely it could be leads to the privacy rights. Next one is the use in warfare and social control. That is, computer vision technologies are increasingly integrated into military system, including autonomous drone, target tracking, and surveillance in the conflict zones. There are also instances where CV has been used by the authorization regimes for the mass surveillance and social profiling. Next one is the call for responsible CV deployment and regulation. That is growing the international consequence on the need for responsible development, deployment, and auditing of the CV system is very important one. That is, institutions and governments and companies are being called upon to the transparent practices, conduct bias assessment, and compile with the emerging the AI techniques. So next one is the we have to move on to the future trends in the computer vision. We are same as that vision language models, foundation models, edge vision, self-supervised learning, neurosymbolic. So these are all the future trends. That is vision language models means example they can use as the clip, that is contextual language image retaining, and the flamingo process, that is the deep learning technique where evaluating how AI can be interact with the world. So vision language models only, it enabling models, that is models that train data set that can understand the image through the text prompt. Next one is the foundation models. Foundation models are trained billions of images, are setting a new benchmark for scalability and generalization. These models are pre-trained on diverse web scale data sets and can be fine-tuned for the wide range of downstream tasks. Next one is the edge vision with tiny ML models for the IoT. Vision systems are being miniaturized for deployment and edge services like drones, cameras, wearable, and mobile phones. So next one is the self-supervised learning. Self-supervised learning is here especially used in the medical imaging and then rare object detection. Next one is the neurosymbolic and general purpose visual agents. Neurosymbolic, it can be the future CV system or evolved into the hybrid architectures that combines deep learning with the symbolic reasoning to enable the explainable and compositional visual intelligence. This leads to a general purpose visual agents. It could be the capture of the planning, reasoning, and interacting with the physical world. So next, how the computer vision, it could be around the global research and industry. So global research and industry, it is a top tier industry that is the newer IPOs. The next one, the CVPR, ICCV. These are all the innovation in the architecture design, research frontiers for the research frontiers. These are all the CNN technique. They have to design a specific architecture, learning, and the evaluation method is there. Yeah, it should set the benchmarks for setting the global research areas. In industry, it can meet the Google, Meta, OpenAI like that. So in that Google, they have to use the CNN networks, efficient net AR4 like that. So OpenAI can be used in that. Many models. Next, AI democratization, we have open source CV models. Open source frameworks like what are the open source memory detection. Open CV model is there. It can be detecting the face transformers to across the advanced CV models. This empowers. It can be used for the developers, researchers who are a startup globally to build the experiment and deploy the vision models. So next one is the real-time deployment. Yeah, in that real-time deployment, it can used as the cloud and edge platform. So cloud and edge platform is the it can be used for the scalable training using platforms like Google Vertex AI, ML techniques like that. In edge computing, it can use the low latency devices that is Apple Neural Engine. So many ML algorithm is there. It allows the computer vision to create the critical applications from the surveillance to the industry and the navigation systems. So many algorithm deep learning and then CNN algorithm is there. And then last one is conclusion. We have to come for the conclusion here. So conclusion, it has the nowadays, computer vision is a reshaping perception across the discipline. From healthcare to manufacturing, CV is redefining how systems interpret and interact with the vision world. It is no longer it's just a technical field. It is a transformative force across the science, industry, and society. So next one is the from pixel to semantic CV powers decision making systems. That is, in modern CV models do not do more that detect objects. It can understand the scenes. It can support the human-like decision making. The journey from the raw pixels to the high-level semantics power automation, safety, and personalized experience. Next one is the global impact. Global impact across domains. It applications across the health diagnostic, autonomous transportation, public safety, agriculture, and AR/VR models. In that, playing the central role in enabling smarter, faster, and more adaptive systems worldwide. Next one is the future. Future lies in the multimodal, ethical, and autonomous system. That is, emerging mission system will not operate in an isolation. They will integrate with language, touch, contextual reasoning, guided by the ethical principles. They can follow some ethical principles, transparency, and societal benefit. Next one, last one, teaching machine to see is the gateway to understanding the world. So computer vision is not just about only recognizing the images. It is about enabling machine to interpret the world and collaborate meaningfully with the humans. It is the foundation for the next generation of artificial intelligence. So thank you.
Yeah, thank you for your presentation. And we have some question from participant already chat, ma'am.
Yes.
Yeah. Hello.
Yes, ma'am. Now only I got the question. Yeah, how can computer vision be applied reasonably in developing where data set may not diverse or representative? After that, should government regulate the use of computer vision technologies, enforcement, and how ethical oversight can be implemented? Yeah, because nowadays, the main thing it could be as the cost. Should government regulate the use of the computer technology? It is a better one. We have to enforce all the techniques. We have to implement all the techniques because nowadays ML and deep learning are fastly growing that one. So we can implement. So it should be very useful for that only. They have to regulate and then follow the some criteria is there. So we have to follow that one. Next, how the computer vision can be applied responsibly developing regions where data set may not be diverse or representative. Yeah, it should be as the trained data set only. So many algorithm is there. Not only it can be used for the specific algorithm. Many terms is there. In the deep learning, it could be claims for deep learning. It has the federated deep learning is there. In that deep learning techniques, we can use the n number of data set. Okay, it could be as we have to represent in that data set. Yeah, we can use the computer vision can be applied for the many regions also. What role does transfer learning play in enhancing the performance of computer vision models with limited data? See, what role means they have to mainly it could be used for nowadays. We can use the facial recognition for the security purpose. So it can detect the objects not only in that only one object. They have to detect entire object in that. They have to if for the person they have to take as the iris and then face. In that face itself many detection is there. They have to perform. They have to enhance the performance with the certain application is there, certain algorithm is there. So, any other questions?
I guess no one else asking again, ma'am.
Yes, ma'am.
Yeah. Before I close this event, for all participants, please open your camera. I will take a picture on the count of three for documentation. Okay, one, two, three. Okay, another one. One, two, three. Thank you for your kind cooperation. Finally, we come to the end of visiting lecture today. We would like to thank you for Dr. Anita for the wonderful information and sharing your knowledge. We hope this information will be beneficial for all participants. At least we hope to have more collaboration in the future. The visiting lecture for today and here. We hope to see you soon. Thank you and have a nice day. Thank you so much, ma'am.
Thank you, ma'am.
Yeah.
Thank you all.